Hello everyone. For class today, I'm going to be going through and doing kind of a general, I guess I would call this the love of coding sort of exercise. I'm going to be sharing with you a project that I've previously coded, talk a little bit about it. And then I'm also going to take this project and place it on my LinkedIn account because the personal projects you guys are doing, the goal is that we want to be able to showcase them, and a good place to do that is going to be on your LinkedIn. Now, I was hoping to have a video where I was going to walk through some interview tips and to go through some problems that you might encounter when you're doing a coding interview. And I have a guest lined up for this, and there's an IT professional from Toronto that's going to be joining me to shoot this video. It just turns out that he wasn't available, and I'm going to be doing this video over the weekend, so it'll be posted for Monday now. All right, so in terms of what we're doing with the course, I just want to stress that you guys should be working on your personal projects. Any issues you're running into, I'd like you guys to reach out, email me, and I'm definitely available to help and provide any assistance. I can certainly look over the code, and if you're getting stuck on anything. All right, so let's move on. So the item I want to talk to you guys about, I've got my GitHub here, and I've gone and I think I followed everyone's GitHub's accounts because I went through and I evaluated your Connect 4 projects. So one of the ones that I want to showcase is what I call magnumchess, and this was actually a project I began working on when I was a student. And it was actually a school assignment that it started with, in fact. And the school assignment was to create basically a program that would play chess, that had the ability to have artificial intelligence and would play chess. And I enjoyed creating this program so much that I basically worked on it for like the next 10 years. It became a really, really big hobby for me to work on. Now you can see here, looking at my code, that I haven't worked on this in quite a while. So it's been at least 7 years since I last worked on it. Well, May 13th, 2013. So quite a bit of time has passed since then. But this is a fairly good example of what you can hope for in terms of your personal project. And doing this personal project, a few highlights I had with it was, because it was posted publicly, is that some people would sometimes email me and ask me about the project, and they would ask for advice because they were trying to do a chess project on their as well. There was even a website, a professional website, because my code is open source and I have a very good license that allows people to use the code. They took the code and they used it on their chess website. So that was really quite fun to see that happen. All right, so let's just go through here. One of the things, because we have it on GitHub, and of course, you can go through and you can see the history, the commit history of this that I've done over the years. Now, one thing I didn't do when you look at the history is I wasn't using branches. So I didn't really, I should have been using branches, but because I was only working on it by myself, I just used a linear workflow with it. But of course, I now know it would have been better to use branches. So if I want to, I'm going to demonstrate this program to you guys. So obviously, because it's on GitHub, I can copy the URL for it. And if I go to my Git, or I'll just open up a command prompt. Okay, so I'm making a directory, and I'm going to say git clone, and I'm now cloning the repository into my local folder. And so now if I go and go to my C drive here, you'll notice I do now have this magnumchess set up. Now, this project, the programming language that I used is Java, okay? Java obviously is an extremely popular language. However, I'm not sure if you guys have any experience with it yet. It is a language that we do teach. You may have had one course already. I'm not quite sure actually. So the reason I use Java is just because it's a language that I studied in school at the time. So when the teacher gave me this assignment, that's what I began using. Now, to be able to run this program, I need to have Java installed on my computer. And as you can see there with the command prompt, I don't have it. So I'm gonna go and I'm gonna want the JDK, okay? So the Java Development Kit. You can also just download the Java Runtime environment, but in this case, if I wanted to ever start working on my chess program again, I would definitely want to get the JDK. And Java is owned by Oracle, or they basically are in charge of it. So the Java Standard Edition 14 is the latest one. So I'm going to download this. Okay. And I want the Windows 64-bit installer. Okay, I've reviewed that. Now the other thing that I don't have right now is I don't have an IDE for developing with Java. But you can easily download those as well, of course. The one that I used to use when I was a student was called NetBeans. And the reason I used it was because it was a very simple one to use. But there are other ones. Certainly Eclipse is a very popular one that you can use. Okay, so I'm gonna install this. So yeah, one thing with the IDE that I used, I mean, you could use just a text editor as well. You could use Notepad++ even, but typically with a fairly large project, you're going to want to use some type of IDE. NetBeans is one. I know Eclipse at the time, like last time I checked, was one that a lot of professionals preferred to use. Okay, so that's been added. Now, let me just open up another command prompt. Okay, so that's interesting. The command, usually you want the Java directory to be added to your path, your environment path. That way you can execute commands. It's interesting that installer did not give me the option of doing that. Let me just try running this again. Okay, so I'm just going to take note of the path. Program files, Java, JDK. Okay, it's going to do the installation again. I would have expected an option that says add Java to your path. What does it say under next steps? Okay, so it just pops up a website here. Okay, let's just try to do this manually then. So I'm going to open up a command prompt. And I'm going to go to C, program files, Java. Okay, here's my JDK. Now the bin file, this is where all of the different executables are. So you can see here I have all these different tools like Java right here. You also have Javac, that's the compiler that will take your Java code and it'll convert it into what are called class files. These class files can then be run by the Java program, the Java interpreter. There's also a JavaDoc tool. which will then basically take my code and create a document with all the comments of my code. So what I want to do next is I'm going to have to go into my command prompt, or sorry, my control panel, and I want to find, I have to add this to my path. Okay, so I go System, and I go Advanced System Settings, and then we have Environment Variables. Okay, so here's my path. So I'm going to edit this, and I'm going to include a new path here. So I'm going to say New, okay, and I'm going to browse and go to, okay, I got to go to the folder I was just at. So C drive and Program Files, Java. And from there, I'm then going to go to bin. And I'm just going to add bin. So basically the binary where all the executables are, I'm going to add this now to my path. All right. So now, hopefully, if I open a new command prompt, it will basically be able to execute those commands. So cmd, and if I go Java, there we go. Success. So we can see here that basically we're able to basically open up the, it's able to find the Java program because I've added it to my path. And if I go javac, this is the actual compiler. So any of the executables in the bin folder now, I can basically from any directory, I can execute. So that's definitely something I need to do when I first set this up. So now if I go back to, my folder here. No, not that folder. Actually, I'll just close this out. We won't need to come back here. So I'm looking at the chess program. We can see that there's a basic directory structure here. We have all the source code. So that's it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 Java files basically set up here that are used for the program. What else do we have? I have a wiki. Okay, so I have a wiki file. I didn't know I did, but what is this? What? Okay, interesting. What else? Okay, so we do have a project file here, so you can see that that's a NetNB project. So that's because I was using the IDE NetBeans. And in the distribute folder, we have what's called a jar file. So when you're working with Java, what often happens is you write these Java files, which contain classes, and then you take them and you use the javac tool. It converts them into what are called class files. But that's still kind of a clumsy way to pass around your work. So often what you do is you create what's called a jar file. And the jar contains all your code and all your assets. And then you can pass that around to people and they can then run your project there. Now I also have a README file. And this basically just talks about how I can run this from the command line. I can type java-jar magnumchess.jar. Let's try that right now. See if that actually works. So I go java.jar magnumchess.jar. And there we go. Okay, so it's working. Now, one of the things that when I created my my chess program, when I first created it as a student project, it was really bare bones. Basically, it could make a few moves, and it had a lot of bugs. It would often crash, and I had a small GUI, and I could play against it. But that was all it could do, and when I started looking into what features I would like to add to my project, one of them was I realized that there's a special protocol that computer chess programmers, they use, and it's called the UCI Protocol. So I could even Google this, UCI Protocol. So Universal Chess Interface, and what this is, it's a series of commands, and it's a way of representing the game of chess that a computer understands. So essentially, if someone else goes and they create a chess program and it uses the UCI protocol, and I go and create my own program and it uses the UCI protocol, then it's very easy for us to basically have our programs play against each other. We can set them up. And I'll show an example of that in a minute. But basically, the specifications for the protocol are basically shown, basically documented online. And it's fairly easy to go and set up the actual protocol. Now, I don't even remember the protocol off the top of my head. So I need to, if I wanted to actually play against it, I have to type in commands that are UCI protocol commands. It's not, I don't see the actual listing of the protocol right here. Okay, UCI technical specification download page. Okay, here we go, here we go. All right, I still don't see. Okay, so that's something I probably need to go and look up. I don't see the protocol listed on this page. Oh, current specification is available as a free download. Okay, okay. Oh, here it is. Okay, download, start download. Okay, so let's take a look at what this protocol is. So these are all the rules. It is a fair bit of work I had to do. Okay, so I've gone through a few of these commands and kind of tried to refresh my memory a little bit. So let's just try to walk through. I can just walk through a few commands and you can see how the engine can kind of think here. Now I've pulled up a chessboard. Let's just expand this image a little bit. Oh, nice. Okay. Okay. Let's bring that to the side. Okay. So the first command that the protocol does is I have to say UCI, and then it knows that basically that's you're basically telling it we're going to speak the UCI command. Because there are other protocols. There's another protocol called Winboard that a lot of chess programs use. I don't think they use it as much anymore, but it used to be the most popular one. So sometimes you would have your program would use UCI or Winboard. So it has to know which one to use. Now I can pretty much start setting up a game. So I could go UCI new game, and now I can, if I want, I could have the program actually start. But I'm going to say, let's say that I'm going to play the white pieces. Okay, the white pieces would be on the board here. So I'm going to move the pawn from E2 to E3. Okay, so I'm going to say position, start, pause, E2, E3. So that's basically moving my piece. And now I'm going to let the chess program go and basically think and then make its move. Now with chess programs, you have to give them an option. If I just say go, it's not going to know how long it should go for, and I think it'll only go for one half move, or what's called a ply. But I can say go depth, let's say go depth 12. So that means it's going to look 12 half moves ahead. And here we go, it's thinking, and you can see it starts to slow down as it hits the larger depths. As well, you can see that there's a bunch of moves that come in basically a line, a text line, after each of the depths. And what that is, that's called the principal variation. So that's actually what the chess program anticipates the best moves at each level that the chess programs and the human are going to play. So it ends up calculating a move of D2 to D4. Okay, that is not quite right. Because I was expecting it to calculate black's move, but it just calculated. Okay, I did something wrong here. Let me just see. Yeah. Oh, okay. Okay, I know why. This line here I was looking at, position, start, pause, and then you have to say moves. So because I didn't do that, so let's try that again. I'm going to go UCI, new game, and I'm going to go position, start, pause, moves, E2, E3. Now I'm going to say go depth 12. Okay, and here it goes. And now it's calculated move. So now the move that it has picked, it has decided that the best move is B8 to C8. So that's right here, B8 to C8. So it's moving its knight out, okay? So let's say I'm gonna do another move where I'm gonna move my knight from B1 over to C3. So I would go start, pause, position, moves, E2, E3, then the next one is B8, C6, and then the next one would be C1 to B3. Okay, and now I can say go depth. Let's make it search a little bit longer. Let's say 15. This could take a little while. So one of the things you'll notice, it's able to complete the first searches very, very quickly. But as it gets further down the search, it slows down considerably. And the reason for that is what's called the branching factor. At any position in chess, you have roughly about 30 or slightly more than 30 potential moves that you can make. So in order for the chess program to evaluate what's the best move, it basically has to traverse a tree where it makes all of its moves, and then it has the opponent makes all of their moves. And it keeps going till it gets to a terminal depth. Then it applies an evaluation function, and then the scores are recursively backed up to the original root node, which then says, it basically says, of all these moves, this one is our best. Now you can see here, it's got to depth 14, but it's now struggling a little bit to finish the depth 15 search. And once you get into the larger depths, because the branching factor is so much, you're pretty much prohibited. Most chess programs, they can't go beyond a certain depth because it could end up taking days before they'll make it to the next depth once they get a certain depth. So right here you can see it finally completed depth 15, and it comes up with a best move of B1 C1. B1 C3. Okay. So I went, that's, okay, so so it looks like my move, interesting. All right, anyway, I'm not sure if I think I might have entered a move wrong, that's all. Let's move on. Now, obviously, this isn't how you would actually play chess. You wouldn't sit there and make the moves in the UCI protocol, right? It's really confusing, really hard to figure out. I'll show you one more thing though. So when I do my search, I could go go. Now there is a command for time. So let me just see here. Instead of go depth, I can say go move time right here. Okay, so I can say, and this is how when you're actually playing a game, you would set it up to use move time, because I don't know how long the depths are going to take. And with chess, you only have a certain amount of time. So I would say go move time, and is that in seconds? Yeah, it's in seconds. So I'll give it 10 seconds, and it'll see how long it can basically go in 10 seconds. Interesting. So I went go move time. I wonder if that's in milliseconds. Oh, XM seconds. Okay, there we go. So 10,000, now it's actually going to go for 10 seconds. And it'll see how it'll probably get to depth, 12, 13, whatever. Now, another thing to mention with the depth, when computer chess programs play, being able to go further along to a greater depth, if say two programs are relatively equal and one of them can go to say depth 14 on average within say 5 seconds, and the other one can only go to say depth 10, the one that can go deeper is going to have a huge advantage and will usually be a much stronger program. Okay. So we've looked at the protocol. Now here's the key thing. You guys are probably thinking, well, do you really sit there, Eric, and type in these commands? How do you really play chess like this? So this is where a chess GUI comes into play. So there's this one called Arena, and this is a chess GUI where you can set up different chess programs. And as long as they use the UCI protocol, you can have them play matches against each other. And that was one of the big things that I wanted to do when I set up my chess program, is I wanted for it to be able to basically play games and be automated. So I wouldn't have to sit there and make moves. Okay, so here we go. Arena for Windows. I'm going to download this. Okay, it's taking its time here. So one of the things that you'll notice here is Arena. It comes with several engines. So these are sample engines, and some of these are actually quite famous engines. For example, this one here, I don't even know how to say it, but Rybka. This was an engine that was developed quite a while. It's an older engine, but when it was developed, it was considerably stronger than any other engine that's ever been developed. And not only it, but then there's a Rybka 3 that came out, I believe, that was incredibly strong and pretty much dominated computer chess for several years before other engines were able to catch up. Okay, so here we go. I'm going to open this up, and I'm going to extract this. Doesn't really matter where. Oh, I'm extracting it to downloads. Okay, not the best place to extract it, but I can just copy it over to my C drive after. So once I have this downloaded, I can open it up and I can basically install my program, and it'll be able to then play. I'll be able to match my program up against some of these other programs that come with Rybka, which is would come with Arena. So Rybka being one of them, which is not anymore, but used to be a world-class program. And I can see how my program does against it, which will be kind of interesting. Oh, it's so slow. Okay, here we go. So I'm going to open up Arena. This is the executable here. Okay, I want English. All right. Okay, so you can see that there's one there, SOS. Now I'm going to go engines, manage. Okay, I need to engines, maybe I go load, install new engine. Okay, so I'm going to go to where I downloaded mine. Now because mine is a Java engine, it makes it somewhat unique. Java it's not unpopular, but usually people who make these type of engines, they usually use the C programming language or C++. And the reason they do that is because those languages tend to run faster, and speed is very important in chess programming because you want to obviously search as deep as you can in the shortest amount of time possible. So using Java is a little bit unorthodox, but it still works. It still is a great language to use for this. So, okay, I can go in, and one of the advantages of Java is I can publish it for the web very easily and put it in a web browser where people can go and play online. Okay, so I'm looking for magnumchess. I do have an exe. Now I have a batch file here, and let's just see what the batch file does. So if I go to my batch file and open it up, so you can see here that this is opening up the jar file, right? It's looking in the distribute file, and there's a couple parameters here. Those are related to how much memory the program is allowed to use. So I'm going to install the batch file. And it's asking me right now what type of protocol my engine uses. Now, Winboard is a popular one, but I don't use Winboard. I use UCI, so I will select UCI, and it says, do you want to start the engine? Okay. All right, now this engine SOS, I'm somewhat familiar with it. And it's a good engine, but I think I can take it. I think my program might be able to beat it. But so we need to set up the options for this game if I'm going to have them play. How do I do that? Okay, so I have options here. UCI options. I need to set up a time. I can't remember how to do it. I used to do this all the time. I can't remember how to do it. Okay, levels. Okay, so here we go. We can set up, there's all kinds of different levels you could do. You can have a tournament game. These are basically time controls. So there's only a certain amount of time on the clock, and the engine, not only does it have to search for the best position, but it also has to look at how much time it has, and it has to calculate how long to take for each move. Okay, so a simple way I can do this is I can use a fixed time per move. And I could give each program 2 seconds per move. The problem with that is it's not really a good way, because one of the programs could get into a situation where it's in a bit of trouble and it needs to use a bit more time to find a good move. And if I limit it to like a hard 2-second time limit, then my program might win, but it might not be the better program. So I'm better off using one of these setups here. So I can go with 2 seconds for the whole game, and I get a bonus per move. Let's say 1 second. Let's go with 1 minute for the whole game. Okay, so here we go. So one of the things, I'm just expanding the lower portion here. One of the things that's occurring is the programs are each basically taking turns. Now, the other program is using oh no, I'm playing against myself. Okay, sorry. Okay, so I'll go engines, manage. Okay, so I can pick an engine. So I'm gonna pick SOS, because I do believe of these engines here, it's not one of the strongest ones. I'm going to apply that. Okay, so now both engines are there. I'm going to say File, New. Okay, and okay, so I've got the same settings. All right, and you can see both engines now have an area here where you're going to see their output of what they're thinking. So here we go. Now you'll notice that the SOS engine, that first move it made a move right away. Often you'll see engines, yeah, it did it again. So it's using what's called an opening book. The openings are there's only so many moves you can make. So the engine is able to save time basically by making a move from basically a database of moves to start with. But once you make a few moves, then you have to start calculating. So another thing that's important to note here is this best move score. So you can see here that my last move I made, I was at 0.22, and the other program, it's at 0.42. Now, in other words, a score above 0 means that the program thinks it's winning. A score below 0 means the program thinks it's losing. A pawn, the value of the numbers, a pawn is worth 1, usually. Depends on how it's programmed. A queen is usually worth about 8.5 or 9, okay? So you can see that both programs think that the game is very even right now. They don't see too much advantage. I think I'm losing slightly. I'm basically a quarter pawn behind. And you might be saying, well, Eric, there is no quarter pawn piece. How can your program think it's behind? Well, it uses positional factors. How much of the board it controls, how much of a threat are the other pieces. So right now, I think I'm losing by by just slightly actually. And the other program now thinks it's losing slightly. So because it's using an evaluation function when it looks ahead, it's basically trying to predict the future, but it's difficult. So you'll see the scores fluctuate back and forth. Uh-oh. Now this SOS program thinks it's up by 2. It thinks it's doing well, and now it's not. So now my program is beginning to take over. I feel like I'm up a little bit. Now another thing too, you can see the actual exchange of where my cursor is, the exchange of material. So essentially, I have lost I've lost a knight, and a bishop was lost by the other one. The material difference now is completely even, but my program thinks I'm ahead. Thinks it's ahead quite a bit. Partly because I've got the king, the white king is now flushed out and is vulnerable, where my king is fairly well protected. But keep in mind, the white piece has the ability to promote. So this could change very quickly. This game most likely would be drawn, I would think. Unless one of these pieces can promote. Now I think I'm behind. So just looking at this position, I would think it would be drawn. But I mean, if one of those pieces is able to promote, this pawn here is the white pawn is very, very dangerous. So if it is able to promote, then I'm going to be in a lot of trouble, So you can see here that, okay, so it did promote, and then it's captured. Okay, interesting. So, I mean, when I first started programming this stuff, I was really like, wow, this is fun. I mean, I can stare and watch this stuff play. There's just some sort of fascination with it. And I don't even play chess myself that much. But I just found it really, really fun to create something and then see it compete. Another thing that's interesting too is that there's actually chess tournaments that you can enter your computer program in. So when I used to develop it, I would make changes to it, I would fix it up, and then I would submit it, and it would enter into tournaments. And you could see that it would improve, and its ranking would increase when you would fix issues or add new features and improve the performance of the program. Okay, so I'm just waiting for this to end. This has got to be a draw, you'd think. I mean, my program is going to try to promote these pawns, and it does have an advantage there, but I just don't think that's going to happen. Oh, it's never say never. I mean, obviously, if I was a more competitive chess player, I would know, where the advantage lies. It's got one pawn left. See if it can do it. Okay, there we go. Yeah, we can see it's trying to promote. Yeah, this has got to be drawn. So basically, they're able to defend against that. Okay, there we go. So we end up with a draw, And basically when you have position that comes about 3 times in a row, like basically 3 times it repeats itself, not in a row, but just throughout the game, at that time the game becomes a draw. So they've essentially drawn, okay? So anyway, I'm not gonna show another game, but just for example, I could go into my engines if I wanted, and I could substitute out SOS, and I could put in Rybka, for example. And this is a huge mismatch. Rybka is considerably stronger. I could probably play hundreds of games between these 2 engines with this time control, and magnumchess would probably never win. It might draw a few times. It might be able to get a draw a few times, but I doubt it would. I doubt it would ever win. So all I'd have to do is just go and set up a new game, and then I could start. Now there are other options in here where you can automate this. So you could basically set up a series of games, and you could then leave the computer running and come back and see the results of those games. Okay. All right. So I kind of want to, like this, I'm having fun doing this, but obviously for the purposes of the class and the video, I'm going to stop here. I do though encourage you guys. I mean, I've shown you guys the steps for installing Java, for downloading, for basically cloning my magnumchess repo, and then loading it into this GUI arena. So you could easily go follow these steps and then test it out yourselves. So what I'm going to do at this point is let's just move on. And the other thing I wanted to mention, so in terms of LinkedIn, one of the whole purposes of having a hobby project like this is having the ability to basically feature some of your work. So I can go into Add Profile section, and I can go to Featured, and I can go to Links. And now I can go over to my URL here for my GitHub, and I can place this as a featured section, and I can then describe this. So basically, this is a UCI Protocol chess engine written in Java. Okay, just something simple. I could, maybe I could add a little bit more information if I had maybe some achievements for it. I could talk about some of the tournaments it went in if I wanted, and I can save that. And now if I scroll down, I can see I have a featured section basically here that shows my my GitHub. Okay, so that's kind of a neat thing that you can add to your guys' GitHubs, and definitely with your personal projects, you want to do that. You want to put something out there that you've been working on. Now keep in mind, this chess engine, it's been a while since I worked on it, so it maybe isn't something I would at this stage put on my LinkedIn profile, but at the same time, it's really can't hurt to do it as well. Okay, so I think that's going to wrap things up. This was kind of, I guess, this was sort of this class, I guess I would call it for the love of programming. The idea is I want to share with you some of my passions and things that I enjoy about programming. And chess programming has been something that I used to really enjoy when I was a student. And it's something I could probably at any time pick up and start working on. It was always a lot of fun to take my engine, maybe enter it in a tournament, see how it did, go make some improvements, go back, and then see how it progressed and how it improved and got better and achieved better results in tournaments. All right, so have a great weekend. Monday's video, I will have a video where I will have an IT professional going over some interview tips and how to solve some challenging questions that you might get on a job interview. So make sure you guys check out that video when it comes about. All right, take it easy. I'll talk to you guys later.